welcome to this second panel. My name is Marion Dumas. I'm an assistant professor at the Grantham Research Institute for Climate Change and the Environment here at LSE. And my work focuses on innovation for the environment in large part. And I'm very excited to chair this panel because we're in a race against time when it comes to climate change and decarbonization and the breakdown of certain ecosystems, so transforming our production systems and the behaviors of consumers and mainstreaming climate change climate change in the decisions of many policy fora, whether on the side of mitigation or adaptation. And these issues are incredibly complex. So there's a need for sort of expert support and so on, and at the same time there's a need for accelerating the development and the deployment and diffusion of cleaner technologies. So research on technological change shows that new technologies tend to break through when they work with the current technological era, when they're bundled with the arrival of a new general purpose technology. So the stakes are very high that the technologies and soft technologies also of social processes and behaviors that will allow us to transition our economies work with AI. If they don't, actually, the legacy system, a fossil fuel-based legacy system, will probably be able to use AI to prolong its life. So I think this topic is extremely high stake and urgent, and it's really time that we go beyond sort of the examples of AI for the planet. Like we've heard lots of cool applications, and that we think about the conditions for sort of a structural breakthrough of AI into this transition. And I think our speakers today are really well positioned to help us think about those challenges. So I will ask first each of them to first introduce themselves and the organization they work for, what it's trying to do, and tell us about where they see the transformative potential of AI in sustainability transitions, in particular in the net zero transition. So let's start with Susanne Knorr. I'm very happy to yield the floor to you.
Thank you. My name is Susanne Knorr. I am a trained geographer and hydrologist, and I'm now the head of place intelligence at Kerb. I've worked a long time in consulting before that, and now, after years in data and being in a big data team, I'm now trying to figure out what's the best place for future deployment of electric vehicle charge points. I work a lot with spatial data and with infrastructure planners and data scientists. I think AI could bring a lot to the table because it obviously speeds up a lot of the processes that we are having in a private company and that and how we are planning. I also think that it contributes a lot to the approach we can take when we consider a bigger area. So Kerb, for example, is one of the leading charge point operators in the UK. So we design, we manufacture, we plan, we deploy, and we operate the charging point network. At the moment, we have 6,000 sockets across the whole of the UK. But to reach the goals that the government has set, with the many sockets that will be needed, we have to scale this up much quicker. And therefore, AI comes in handy, and also obviously data comes in handy to have a better approach in planning and to understand what demand is basically should be met. I think there's I don't want to make this a use case themselves because we want to talk about what kind of in a global or in a bigger scale impact that I can have. I think the big challenge is to get a hold of the data so that we can work with it in a big scale. and this is where AI can help us and where we can deploy it. But yeah, I don't want to speak too long for this intro, so...
Yeah, that's Sam Young from Energy Systems Catapult.
Hi, I'm Sam Young. So I lead the AI team at Energy Systems Catapult, and we are an independent research organisation whose purpose is to help accelerate innovation to a net zero energy system, focusing on that kind of like actually making innovation work in the economy. And before that, I was at National Grid. And when I took this role, the hiring manager said to me, so what I want you to do is look at what's happening with AI and what's happening in the energy sector and work out how to make those two things work together. So, nice small job description. And part of my role recently has been on a program called ADVICE, the AI for Decarbonisation Virtual Centre of Excellence. You can see why we shortened it. To look at what are the real systemic challenges for decarbonising the UK economy, and how might those be addressed with AI? So for me, one of my big bugbears is when people think about applying AI to energy, they often think about the relatively obvious things. So for me, the classic is we're going to use AI to fly drones and inspect overhead lines and process the images and find defects. And I was like, yes, cool. But for getting to net zero, the challenge is not slightly reducing maintenance costs on our existing network. The challenge is we need loads and loads and loads of new infrastructure, and we need to build that really quickly, and that's a huge challenge. And there are all sorts of, as you get into the detail, challenges that you don't realise. So, for example, you may think, oh, so we need to build lots of wind farms, but the challenge isn't so much building the wind farms, it's how long it takes to connect them to the electricity grid. At the moment, it takes 12 to 14 years to connect a wind farm to the electricity grid. It's that's the challenge, not the building the wind farms quickly. And so there's a bunch of systemic challenges, and in ADVICE we've been looking at those, and I'll maybe mention a couple more as we go through, where it's not about is there an obvious application of AI, it's what are the things that are really slowing us down, and how can we think around the edges of that problem and come up with ways to accelerate those with AI.
Great. Daniel, behind me, Daniel Erasmus from ClimateGPT. The floor is yours.
Good morning, everybody. My apologies for being virtual. I'm being called back here. I'm speaking to you from San Francisco, and I'm being called back. So just given the carbon weight of going back and forward, I decided, so my apologies being virtual. Our view on this is slightly different. So there's a set of technical optimizations that we will go through in various systems. So the energy system, and these things are fundamentally important because in the end, our society is built on technical infrastructure. AI is often positioned as an optimization technology, and we approach it slightly differently in applying similar underlying technologies. But here is a decision augmentation technology. So between here and a sustainable future, we will be taking thousands, hundreds of thousands, millions of small decisions to change systems, to go for technology A versus technology B, to go for various levels of optimization, different policies, different economic incentives, different regulatory, different discovery mechanisms inside this. And so we're using AI to support those decisions by helping expose the best research we currently have, and that's within the boundaries of what this technology does. So you can just simply ask the questions, and by exposing hidden interconnections that we perhaps would not have seen as extreme weather events and extreme system failure cascade through the system. And early action matters, smarter action matters, and the pacing here, AI can give a unique capability for pacing and scaling up the expertise.
Great. So these are sort of at the very high level. And I think now it would be nice to hear a little bit about some of the applications that are going on the ground at the moment before we think about, well, what's holding us up for, going the next level. So let's start with you, Daniel. Can you give us some examples of where this generative AI is transforming or really helping decision processes related to climate change?
Transforming is really early. We basically released the technology COP and then public available in January. So the utility of the platform and it's available, it's free, it's for everybody, just simply apply at ClimateGPT.ai and we will continue to make it so. Has been from very odd and unusual places that were non-obvious. So it goes from the sort of obvious thing is help write an ESG report or submission for company XYZ, and then people would add documents and various things to that, or what are the best carbon, sort of ways of decarbonizing apparel industry. There'd be very specific companies, or what are the vulnerabilities in supply chains here, all the way to striking questions. We've had a set of questions from the Sahel of how people have used it, and that is, I mentioned this in some of the preparatory chats, and so which livestock would be most climate resistant in the Sahel, and then it gives an answer. And it cites various academic references and would say, cattle is perhaps not the best choices, but camels and goats are there. Or what are the mangrove structuring that one can do, and what are the costs associated with that. A lot of it has been institutional use and policy use, from Madagascar to Argentina to sort of the major policy units in the European Union.
Great, thank you. Turning to Susanne, so in the world of EV charging and maybe smart grids and infrastructure planning, what's right now the state of the art in terms of using AI, in the UK context, or if you think there are front runners that are doing better than the UK, we're happy to hear about this as well. Especially where we would really be doing noticeably worse if we didn't have those tools.
Interesting question. I think definitely from the lens of EV charging, there's definitely countries that are a little bit further ahead, but I think the question is also about scale, and there's also countries who have very big visions and have also very big budgets, but maybe do lag behind when it comes to deploying charging points, and AI can help us a lot there. So that is one side of the coin. I think there's a bigger challenge that comes maybe with the more of the construction side of the whole deployment of EV charge points, and that is very similar to all kind of construction of big infrastructure projects that are needed for the sustainable transformation. And wherever there's different partners coming together in construction and different companies coming together and working together, especially in the public space, where we see that these big projects are be tendered. So that means that there's very often a price, and a competitive price is very often a big argument that research and development gets maybe a little bit neglected, and therefore there's not enough space for having actual data scientists on every partner company's side, and having them work together really effectively, so that we could use the good benefits of the data, that we could streamline the data. And we heard before, the biggest challenge is very often the cleaning of the data, the organizing of the data, kind of managing it. You need a data engineer, etc. And if these projects are not financed in a way, and this is not put down into the kind of requirements, and this can be a struggle. And I think this, we should not miss out on this. I think there's great, there's such a great opportunity in there, and if it is very difficult, I think, in the whole construction sector to bring this change bottom up, because there's a lot of regulation, and every region has different building regulation, every country has different building regulations. When we go into very, very large projects, then you also see that they are just built differently in different countries, and they are very unique. And I think there is a kind of a big opportunity when there could be reached a certain level of standardization to be then enabling a bigger use of data and AI at the end of the day, because at the moment it's very use case heavy, which is great, and there's amazing use cases, but I think to kind of give it this big push, there's a big need for standardization also for, and I don't want to take a point from you, but I think we work a lot with transmission grid operators, and there's also these organizations that are kind of responsible for the grid. And to connect charge points, you need to know how much capacity is on the grid, and if you can actually connect the charge point, if there's enough power there. And how great would this be if I could see digitally, before planning, before suggesting this site, that there is enough power there, or that there is enough headroom there, and this is, for example, not even standardized. There's moments where I speak with responsible colleagues, and they say, we actually look at the paper maps, and I'm like, oh, okay, good. So it's not, we have, I think, some fundamental work still to do, but I think there would be, once this is done, this could accelerate.
So I'm hearing basically that on the ground, actually, we're not seeing a whole lot yet, because we're missing some sort of fundamental prerequisites for people to be able to work together using these capabilities. And is that, well, Sam, your turn, because I think you have similar sort of stories up your sleeve.
I think I'll share a couple of things. So one is that we all know that access to good data is really important for AI. And that's something that we've been working on for several years and are starting to see some of the fruit. Though people like Susanne find it painful, actually there's been quite a lot of work in opening up regulation in the UK so that there's this concept of presumed open data for networks. So it used to be that the networks were like, well, it's our data, it's commercial, and now they have a requirement where actually if someone requests it, well, by default it should be presumed open, and the regulator expects them to have a really good justification for why it isn't open. And so that's starting to unlock some of the use cases, but finding that the challenge is it's not just they didn't want to release the data is not digitized, maybe doesn't exist in an easy format. So I think there's progress there, and it's kind of building momentum. I think what's interesting as well, though, is the cultural element. For me, this is typified in my story of my best ever and worst ever data science project. And it was exactly the same project. And so an engineer came to me and they said, we've got this spreadsheet of information about things on the electricity grid, assets, pieces of equipment, and we think they're unhealthy, there's a problem with them, we're going to have to replace them all. Please could you wave your AI magic wand over it and tell us what's going on and whether anything's right. And if you're a data scientist, you'll have heard that before, like, you're meant to do some magic with data. And so I was like, all right, fine, sat down, started going through this, like, analysing it. I go, did you know this? And he goes, yeah, we knew that. Did you know this? Yeah, we knew that. And I'm feeling pretty ignorant. I'm not an engineer by background. And then I come up with, like, did you know that this group behaves differently from this group? And he goes, no, really? I'm like, yeah, like these ones and these ones, they look very different. He goes, that's interesting. And he pulls up the design drawings and he looks at them and goes, yeah, you know what? There's this little like bit here that I could see why that would change the electrical field strength, at which point he lost me, and go do some modelling simulations and come to the conclusion that there's a design flaw in some of these, and that's what was causing the things they were concerned about. And at this point, I'm like, I am a data science superhero. I have found something that an engineer didn't know from data. This is what we're all meant to do every day. If you haven't done it, do it. And then, so we sit down together and we work out, right, so we can, we don't have to replace all the assets, we only have to replace these ones. We write a paper for that, we take that to the engineering committee, and the senior engineer says, oh, but if one of those assets explodes, then it could kill someone. So there's a high safety risk if we get this wrong. And you don't have a lot of data to produce this. And we did see a couple of those kind of like start to show signs that they might be having problems over in this other country. So I think we need to collect more data. And I do some analysis and go, if we collect more data and analyze data on all of these assets on our entire network, we would be basically no more certain about this result than we are now. And the kind of committee discussed it, and no, we need to collect data for another year. Come back in a year later, and as I said, we were no more certain. Oh, we need to collect data for another year, and another year. And as far as I know, we have spent millions of pounds replacing those assets that didn't need replacing. And it wasn't because we didn't have the data. We had the data, it showed something. But it was this communication and cultural challenge in how do you engage with the engineers in a way that they kind of understand, can put their trust in these conclusions. And that was where I wasn't a data science superhero, I was a data science failure in failing to actually convince and engage with them to actually change the decision. And we see that quite a lot, that actually it's the how do you actually change the decisions. It's not the have you done something fancy with AI and do you have the data. It's the how do you actually target the applications that have decisions and then actually work with the people who make decisions to change them. That's one of the really hard things and the real challenges that we have.
Do you want to respond to that?
Yeah, I wanted to add something also positive from my side to that. We have, as you said, when you have lots of assets, you can also generate lots of data, and you can collect lots of data from your own network or from your own assets. And this can be a strength if you have a lot of assets, and you can then start playing with it. And that's really cool, because if this is your organization, it's basically your data, and if it's anonymized, you can do lots of fantastic things with it. And what we have started is we have assessed the charging stations that we have so far, and we have gotten really good insight about which ones go really well and which have a really high utilization. So where do people really like to charge, or what has happened there? And like, do people have a best charge point friend, so they always go to this charging station? Or is there a family that is actually sharing this on-street public charge point, so they come and return? Or is this really visible, or is this probably not visible at all, so no one has ever seen or heard about this charging point and never goes there? And we could take this and bring it into the future planning, so that I get automatically suggestions that look like very well-performing charge points. And that is amazing, because I can come back and can say, these are really promising, and once they will be deployed, they will show a similar utilization. And with that, with such an argument, you can then convince more decision makers to also give you probably a little bit more power, to trust a bit more in this decision making, trust a bit more in what you do as a data team. And yeah, I think that is really where the kind of magic lies, to help with the culture change, especially of decision makers who don't have a deep technical interest or background, but are still crucial in the decision-making process. I think it's a very important point that you raised. Yeah.
Great. So I think we're talking about applications. Like unlike health or the previous panel, where we can kind of immediately imagine that we all have lots of data, flowing out of us basically, and that you could imagine pretty easily how you then use that to make decisions and optimize your medicine and so on. I think in the case of the sort of broader energy systems, agricultural systems, and so on that affect sustainability, it's a little bit less obvious to us as citizens, to the end user, how AI can be brought to bear, but also to all these kind of professions that are used to very capital-intensive assets, not necessarily the most innovative sectors in the economy. And so this cultural divide and the need to partner across, like large infrastructure projects that require city planners and regulators and multiple professional bodies, etc., bringing in this sort of core innovation in this process is really, really challenging. So you started talking a little bit about that, and I'm wondering, to what extent do you feel like there's a need, does that mean that we kind of need to train a lot of people in those tools so they can actually understand them, and that maybe there's a limit to communication if they themselves don't start having some skills and knowledge of it? And I'm thinking in particular, in regulators of the energy systems, or in the case of Daniel, do you think there are large barriers to the uptake of your expert system in decision processes? Will people trust that, and so on and so forth? So maybe let's talk a little bit about this issue of skill gap in being able to bring AI to bear. Daniel, do you want to say something to that?
Yeah, I mean, I think there's a data component to this, and there's a decision component to this, and one of the key things that we decided in making this interface on ClimateGPT was that there are multiple perspectives. So rather than just giving one answer, it gives us a general answer, and then it gives a scientific answer, an economic answer, and a social answer, and it can give a risk answer, and it can give an implications or an innovation answer, and then at the enterprise use you can also go for regulatory answers, scenario answers, etc., etc. But from the outset on the interface, one confronts decision makers or people who are just exploring the territory with multiple perspectives. And one of the key mistakes that was made in operations research, in the 50s and 60s, was this idea that there's one optimal answer. And we hear the rhetoric come back in sort of technical optimization of systems, that there is one optimal there. And one needs to confront that there are multiple ways of looking at these things, and these multiple ways often end up in various conclusions. And I remember my old professor used to say, the name of the devil is sub-optimization, which, always, said that you're inside a super system which has a thing, but it gives a sense of an optimal there. And from certain very small technical systems are optimals, but we are in a transition moment in which there are multiple competing technologies, many of those with path dependencies, many of those generating alternative technologies, almost all of them on experience curves, meaning looking forward matters, because certain technologies are on faster experience curves than other technologies and will be cheaper. Certain technologies are distributed. So we need to represent to people the complexity of the space and create a tooling where they can ground their decisions from multiple perspectives and build contingencies. One of my favorite books here is actually written about the piers down in San Francisco. It says, how do buildings learn? And he talked about the piers on the docks, and they would change from being warehouses to becoming office buildings, to becoming now entertainment things, to becoming chocolate factories to there. And how you design that building can enable it to learn faster or learn slower. If you build it at a slant, the building can only be used as a parking garage, but not anything else. If you build it slightly differently. So decisions in systems early on matters, and we should be designing systems with these kind of contingencies and preserve these multiple perspectives, and not just fall into the same traps that we did with hard operations research in the 60s.
Interesting.
And if I can come in on that, I think the whole systems perspective is really important, and you probably don't appreciate how important that is, but just to give you a really simple example, heat pumps and electric vehicles, right? We need to decarbonize our domestic heating and our transport. We're not adopting those quickly enough for us to decarbonize our economy at the pace we need to. We need to push faster. Problem with that, we also need to build more electricity network to cope with that. And you don't need to build it everywhere all at the same time. You need to know, where are the EV chargers going to be? Who's going to put a heat pump in first? And actually that kind of thinking about all of that. But then you have the layer of skills, not just the data skills, but the installer skills. Can people install heat pumps? What skills do they need for that? We have a big skills shortage there. And so I think that whole systems perspective is really important. And to pick up on something that was said in the previous session, there's a really important element of resilience. And if we optimize too tightly to a specific, all these things are going to line up, what we find is actually we undermine the resilience of those plans, the resilience, and that's where we have a real challenge, particularly when you think about using AI for optimization, is when you're thinking from a narrow technical perspective, you focus on how do you optimize, what are we trying to optimize, and you have to define that more and more narrowly for the problem to become tractable, but actually that's really dangerous because you are optimizing on something that is only part of the bigger picture, and that can threaten kind of like the wider ecosystem as well.
Great. Did you want to add something?
Yeah, maybe something very small, like just a small comment from the consulting and building industry. When I worked at Arcadis, we had a big global program, and we trained lots of consultants in them skilling up when it comes to data and being data scientists, etc. And there was a great uptake of many young consultants, and it was wonderful to see because they did not only build on their own skills, but they also kind of brought this into big projects, and it was really amazing to see the change that they brought. At the same time, we realized we're competing here with the tech market, which is paying different salaries than the construction industry, and you have to kind of balance this. A lot of, if you do it for the money, you would not work in the construction industry, I guess. So I think it's a good time to be a data scientist, and I think you can go into many sectors to have a positive impact, especially if you want to do that for meeting the net zero goal and engaging yourself in the kind of sustainability challenge.
Great. I think we might be able to now move on to the Q&A. So I think there will be a roving mic.
Thanks very much. Really helpful and informative discussion. I have a general question. There's been a lot of talk about reducing to net zero. But there's been hardly any talk about the recent technologies we've been using, right? Cloud computing, training these large language models. Has there been any studies done regarding how much of a carbon footprint these technologies are causing? And if there are, could you kindly guide us where to look?
I think, Daniel, you might be well positioned to answer that.
I guess this is coming to the word. So in the case of building, I'll do the specific case and then we'll do the general case first. So in the case of building ClimateGPT, we very purposely decided to build it with green power and also run the inference, meaning serving answers on green power. And this was a non-trivial challenge, getting access to GPUs, which are in green power. We were very gracious in the end. It's in Washington State. We got a hydroelectric, the data center next to a hydroelectric installation, and the same in the Netherlands. The servers stand in there based on green power, wind power predominantly, so some solar mix in there. The paper itself is publicly available. We counted the amount of carbon to build a model, obviously running on green power.
Yes, I think that's the first paper I've ever seen that actually puts its carbon footprint right at the top, and this should become maybe standard academic practice.
Thank you for that. It was a set of internal discussions. There's 27 authors, so we all kind of worked at this very hard. But But I mean, the point here is it was doable. We wanted to show, at least build some level of a case study on responsible AI and how to do this. I unfortunately can't say that echo through the whole industry. And the way that these chips are done is, heat is a significant byproduct of that. And smarter data center designs and more forward-looking data center designs will harness that heat, either convert it to energy or to district heating. This is not just that these chips are inefficient, but the heat produced from this are very valuable and can be used in many, many different ways, given that, something like 40% of greenhouse gas emissions are from buildings, heating them, supplying them with energy, and making them. There are significant opportunities there. That's not currently the case. Many data centers I've seen have these massive radiating, just to radiate the heat into the sky. So there are deep shifts here. If we look at the industry as a whole, the expectations are, and this is one of these silly extrapolation graphs, you tend to get inordinate amounts of, I think they're projected by 2026, AI will be using the same amount of energy as Japan, for example. And I didn't quite trust the numbers that came through last week, but it's a matter of harnessing the heat in the larger picture and building systems that can apply that heat.
The other very quick point that I would say on that is that whilst the electricity demand from AI is increasing rapidly, in the medium term, that demand for electricity from AI isn't the biggest challenge in terms of demand for electricity. It is electrical heating, it is electrification of transport, and so it's not that we shouldn't worry about that, but we shouldn't get overly focused on, let's focus on solving that challenge. Actually, we need to think about how do we solve for these big electrification challenges, of which that's just a component.
Yeah. Very well said.
Thank you for that.
Great. Next question. Yeah.
Okay, my question is, you are talking about ChatGPT for climate, and I would like to understand a little bit about the structure or the infrastructure. Are you talking about data infrastructure or software infrastructure? You combine both. The second question is, how do you adapt? How do you make an adaptation of climate in any sector? For example, I'm involved in agriculture, and I would like to predict the adaptation, the climate adaptation, the next, 5 or 10 years, for example. This means the data. This means the question is how, I don't understand how you can, it's a digital twinning at the end, because you see at holistic way, this means you need strategy. And therefore, where is the strategy in a long-term strategy to have this kind of knowledge economy in the context of, let's say, in the context of the holistic approach? Where is the data? This is what I'm worried about. We don't think we need some kind of observatory data before we start all this, let's say, knowledge observatory data before come to any say, scenario or decision. Thanks.
Right, so I think the question relates then to the sort of data infrastructure. What's the vision for the data infrastructure that will power the decarbonization and much more sort of data-intensive management of the planet, really? So that's a big question.
And I'm sure Daniel will want to jump in on this one, but I'll get my 2 words in first, which is I think we're in a hurry, right? We face this challenge of we want to have evidence-driven, data-driven policy, and we need to decarbonize quickly. And so we have to make sure that we're optimizing for both of those. And so that involves like using observational data that we have from kind of historical data, even though that's not the gold standard randomized controlled trials. It involves using kind of poor quality data, even though ideally we'd go and fix it up. It involves having to stitch together a whole load of non-standardized data instead of forcing people to standardize it so it's easy. We have to be working to make the underlying data better for the long term, but we also have to get the job done and move forwards as quickly as we can. So I think in a lot of what we do, it's trying to do those two things of like, how do we improve the data quality, improve the data availability so that more data is available for decisions, but how do we make the best decisions that we can now on the data that's available now? And that's a real tension to kind of like hold.
Mm-hmm. Do either of you want to jump in?
I'll do it very briefly because I want to give Susanne an opportunity. I thought, Marion, it was a lovely way of the way that you phrased it at the start of the session. You talked about hard and soft technologies, and being in the middle of technology, in the middle of AI. I'm quite a softie here, and there are reasons for that because it's the soft side of things and the soft infrastructure, and want to really emphasize the discussions on the soft infrastructure here and the interplay between soft and hard infrastructure. The role of AI in what we're doing is really simply helping make better decisions and help make interconnections. It doesn't mean AI will always be right or any of these type of things, but it helps accelerate a set of decisions and accelerate a set of understandings that would have been hard otherwise, particularly the hidden interconnections that we wouldn't think. And just touching on Susanne's thing, it's doing God's work. I mean, I'm here and I'm just putting this to the screen here. This is an app here that lists the various plugs on electric cars to figure out where to charge your car, because some of them work and some of them don't. And we literally have an app that has to guide us through something that's clearly, in my entire life, I have never, ever, ever gone to a gasoline station or a petrol station, benzene, and had the thing didn't fit into the car, ever. Across the whole world, this has never been a problem. And so there are clearly a role for system design and regulatory impetus here, because this is, doing this work here is God's work, and where we are now is a long way from where we need to be. And it's this soft infrastructure that plays rather than this overstate the role of any technology. And I'm saying this as a technologist.
Yeah, so I think, Susanne, do you want to expand a bit on your concerns with standardization? And without that, we really, really can't, harness these tools.
I get your point there, Daniel, with the different plugs. I think that's not ideal, and I think also that's it's not a good user experience. So much to that. When it comes to the data, I think what you said, Sam, is I would second this absolutely. There is a lot of things that still need to be done. We need to have better data infrastructure. We need to have cleaner data. How we generate the data needs to be much better. We need to find standards so that we can also exchange data better. We need to have better collaboration across different partners who are working with that. But at the same time, I think this shouldn't stop us from doing it, because the time's ticking and we need to get going. And I think that's maybe my 2 cents at the end. Standardization is very important, but don't let it scare you. Let's start.
Great. I think unfortunately we're at the end, but I think we can maybe follow up during the break. Thank you very much for your insights and for your time.